All right, class, welcome to chapter 7. In these last 3 chapters of this course, we will get away from functions. So we're done with functions, all the types of functions, the graphs. Well, we will graph today in this chapter, but they're not going to be functions. So in this chapter, we will discuss something called conic sections. So conic sections is what type of shape you will get if you would take 2 cones, as you see pictured here, top and bottom, right? And you slice them with a plane. So you have to kind of imagine these as being 3-dimensional pictures. That's what the shading, the dark blue shading, is trying to suggest to you. So the one conic section that we're missing for some reason, because usually circles are discussed in intermediate algebra and lower level classes, which is also why I took the textbook section that I posted for you actually comes from an intermediate algebra textbook. But I do want to discuss circles for completion. So if you go straight up with a plane and you slice the cone, you're going to get a circle as a cross section, okay? So the circle is a conic section as well. As I said, it's just that it's usually discussed in lower level math classes. If you go a little sideways with a plane, it's an elongated circle that you get, also called an ellipse. It looks like an oval, but we call it an ellipse. If you go straight up with a vertical plane, you're going to get almost like 2 parabolas that are back to back. That's called a hyperbola. And if you go sideways, but you're falling out at the top, you just get this parabola, which is a parabola. So that's what you get. Okay, but if you go straight up and down, these are back to back, straight up crossings. They're not actually parabolas. A parabola, you have to go sideways, but you would get, they look like parabolas, but they are called a hyperbola. So again, the difference between a hyperbola and a parabola, that the hyperbola looks more like a V with a rounded edge, as we will see when we get to that section. And in a parabola, it's looking more like a U, so it turns up the sides. They don't go like a V. They don't go almost linear. Okay, so that's the difference. All right, well, first things first, we're going to discuss the circle. Okay, so this is the easiest one. The circle is simply geometrically the collection of all points at an equal distance from a given point. So we start with a given point, which we, by the way, call the center of the circle. And then we go all around in all direction with an equal distance all around, which we call the radius of the circle. So I'm just going to pick a distance, and then I'm going to move all around this point by this equal distance. Of course, I cannot draw a beautiful circle. That's pretty good. But that's what you do. If you go all around by this same equal distance, you will get a circle. Okay, so we call this the radius. And the point in the middle that we started with is called the center. Now, the equation that describes all the points on a circle with a center in the origin. So let me draw one for you. Of course, this is what we do. We place these shapes. We're going to graph them. And we're going to graph them on the XY plane. And so here it is. What if I put the center in the origin of the XY plane? And then I'm moving with some kind of radius R all around. So again, well, not quite circly, but here it is. So we're moving all around at a distance R from this center, right, at 0, 0. And so what we want to do is we want to describe all these points, x comma y, that are on this circle. Okay. Now, as you see, the circle does not describe a function as it does not pass the vertical line test. Okay. So it's not a function, but it still should be able to be described with an equation in two variables. And I'm going to show you where that equation's coming from. If you draw this little circle, which this little triangle, which by the way is a right triangle, the fact that this point has a coordinate of x, that means when I look back at the x-axis, that's the number. It also means that the distance from the origin to that point is x. So let's say this would be a point of coordinates 2, 3. That means this is the number 2, but then also the distance from 0 to 2 is 2 units, right? So that's why this distance there is going to be an x. And then by the same token, the distance up here is going to have to be a y, right? Y units up, okay? So you go x units to the right, y units up, and there you go, you arrive at that point of coordinates x comma y. But again, as you see, what we are dealing here is right triangle. So by Pythagoras, I don't know what I'm writing. By Pythagoras theorem, which we reviewed back in the review chapter, x squared plus y squared is r squared. So one leg squared plus the other leg squared is the hypotenuse squared. So this happens to be the equation of a circle with center in the origin and radius r. Okay. All right. So again, if you remember back on chapter 1 when we started talking about functions, we even looked at some equations and I said, does this equation in two variable describe a function? And we concluded that any time y was being squared, then that was not a function because you don't get one solution for y, but you get two, right? On any x possible, you get two possible y's for it. So that makes it not a function. If we shift the circle off the origin a little bit, it's not a big deal. They don't have to be centered in the origin. Let's say we move the center to a point of coordinates h comma k. So really what it does, let's say the radius is still an r. So really what we're doing is we're shifting the circle from 0, 0, yes, and then we're just going to get an x minus h squared plus y minus k squared equals to r squared. So if the center shifted to hk, then we simply subtract those values from x and y. Okay. All right. So here it is. Let's graph the following circles. It's actually pretty simple and it's really easy. So the first thing I need to decide is where is the center. And the center is what's going to be subtracted from x and y. And as you see, nothing is subtracted from x and y. We're going straight to a equation of a circle with center in the origin. And then the radius, be very careful, that 9 is what's the radius squared is. Now, of course, when we square root both sides, we should be getting a plus or minus, but a radius is a distance, and as such, it cannot be negative, right? It has to just be a positive. So, because it's a distance, so we're going a positive distance all around the origin. So there you go. what describes all these points on this circle is the equation that says that the x coordinate squared plus the y coordinate squared is going to be 9. The x coordinate squared plus the y coordinate squared is going to equal to 9, and so on. All right. Let's again, first of all, there's two things that make up a circle, a center and the radius, and that's it. So where's the center? Again, remember, think about the opposite. What's subtracted from x? What's subtracted from y? So from x, we subtract a -1, and from y, a 3. So we're starting at -1, 3. And then the radius squared is 4. That makes the radius a 2. So from here, I have to go 2 units up, 2 units left, 2 units down, 2 units in every direction. So here is my circle. There you go. Again, you try this one. 2, -1. Again, think about what you're subtracting from x and what you're subtracting from y. R is what's being squared here, and that's a 4. So I'm starting at 2, -1, and I'm going to go 4 units in every direction. And then I'm going to connect these points nicely with the best circle I can produce for you. All right, and that's it. That's all it is. Pretty simple. Now, as always, we want to go forwards and backwards. And we want to, okay, given the equation, draw the circle or find me the center and the radius and graph the circle. And now we want to go backwards. Given the center and the radius, can we go back and write the equation of the circle? Sure, no problem. X minus 0 squared plus y minus 0 squared is equal to the radius squared. And 2 squared equals to 4. And done. Find the equation of a circle with center at 4, -8. So x minus 4, y minus -8 is equal to the radius squared. So when I fix this, there you go, x minus 4. Do not distribute anything. Leave it in this factored form. X minus 4 squared, y minus means a plus, yes? And 6 squared is, of course, 36. Okay. So just how easy it goes. And here's one more. The last one is a bit trickier. Then it goes back to the R3 sections that we discussed. We're going to need the distance and the midpoint formula. So just as an idea, I have to find the equation of a circle with end points of the diameter at -3, 8. Let's say, it don't need to draw it. I just am trying to give you an idea. And 5, -10. So we want to find the equation of this circle. The endpoints of the diameter are at, these are the coordinates. Now, again, to find the equation of a circle, we need the center, yes? And the center happens to be halfway between the endpoints of a diameter. So to find the center, I need to use the midpoint formula. And if you remember, the midpoint formula is you're going to have to add up the x's, average the x's, and average the y's. So therefore, the center is going to be at -3 plus 5, which is 2, divided by 2, so that's 1. So the point halfway between -3 and 5 happens to be 1, which makes sense. And the point halfway between 8 and negative 10 is 8 plus negative 10, which is negative 2 divided by 2, which is negative 1. So there is where the center is going to be. So we have to use the midpoint formula. So by the way, the textbook file that I have posted for you for this section, as I said, it's out of an intermediate algebra textbook. And actually on that section, it does introduce and review the midpoint and the distance formula. So it's part of the textbook as well, if you want to review those two ideas. So there's that. And then, of course, I need the radius. Yes, so the radius is going to be this distance between the center and either one of the endpoints. It doesn't matter. Or you can find the distance between the two endpoints and then cut it in half, right? So the radius is half of the diameter, right? So we need to use the distance formula. And I'm just going to use the distance between these 2 points. It doesn't matter. I'm going to get the same answer if I go from 1, negative 1 up to 3, negative 3, 8. So the distance formula is the square root of the difference between the x's, x1 minus x2 squared. Look it back up to the review R3 section. And then the difference between the y coordinates squared. So subtract the x's, so 1 minus 5 squared. It's basically the Pythagoras theorem. Plus subtract the y's, so 1 minus minus 10 squared. So let's see what we get. 1 minus 5 is negative 4. Negative 1 minus minus 10, or negative 1 plus 10, that's a 9. If you square the 4, you'll get 16. If you square the 9, you'll get 81. So you will get the square root of, I'm just going to say 97, right? Now, remember, to write the equation, let me write it down below, is going to be x minus the x-coordinate of the vertex squared plus y minus the y-coordinate of the vertex squared. Yes, here it is. The x minus the x-coordinate of the vertex squared. Y minus the y vertex, I'm sorry, center squared. It's because I'm thinking back, it's very similar with the parabola formula. The h and k we used as coordinates of the vertex. So that's why it just in my brain started talking about vertex, but it's a center. So unfortunately, yeah, we call them also h and k. So if I simplify this expression a bit, again, do not distribute, but I do want to change the minus to a plus. And I want to change this number, this r squared, does not always have to be a perfect square, because the radius doesn't always have to be an integer. It doesn't have to be always 2, 3, 4, whatever, some number that's easy to count with, right? Could be a decimal number. So it so happened the radius is whatever the square root of 97 is, which is about 9.6-ish, I'm going to say. But when I square this square root, I'm just going to get 97. So it's not a perfect square, right? The radius is the square root, right? You have to take the square root of this number every time to find the radius, right? Now, sometimes that number does not have to be a perfect square, right? It gives you a decimal value. That's okay. So I'm just showing you that we have to square the r, and when you square a square root, it goes away. So that's the equation. All right, and that's the section. It's actually pretty straightforward, simple. You'll just practice on these couple concepts going forwards and backwards. In other words, given an equation, draw the circle easily. And given this center and the radius of the circle, or maybe you need to find them with the midpoint and the distance formula, write me the equation of the circle.